All right, hello world. This is CS50 Live. My name is Colton Ogden, CS50 Live. If you're unfamiliar, is a show based on the course CS50 at Harvard, taught by David Malan. And this show is kind of a spin-off where we program a bunch of things from scratch, talk about technologies, cool things. We have a lot of guests come through. Today it's just me, and we're going to make a game from scratch today. And the game that we're going to make is probably a game that you've seen in recent years. It's a game called 2048. And I think what we should do is right away, just so we're clear exactly what we're aiming for, maybe show what the game looks like. I apologize for the fact that the chat widget seems broken today. I'm not sure why that is. I think it's an OBS software glitch. But we will try and get that up and running for the next time. But I will try and read all the chat out loud so that we can, at least so the viewers can see what people, or at least hear what people were saying at the time. So I'm going to switch to my computer here. And then I'm going to actually go to, I believe it's 2048game.com. Yep, it is already. Actually, I have it already set up. And you might have seen this before. This was popular, I think, back in like 2014, 2015-ish. And apparently this was coded in like a day or something like that, or a very short period of time. And the way the game works is that you have all these numbers. It looks like it's actually cached based on my prior score. Oh, you know what? I think I might have actually played this on the last stream as a preview for this stream. But anyway, you move all of the tiles sort of at once in one direction, up, down, left, or right. So if I press up, all the tiles are going to go up. So you can see I pressed up. They all went up. And sort of the gimmick of the game, the way that it works, is that any two equal numbers will combine together and add up and just become one tile. So for example, there's two 4s there on the left. So right here, these two 4s. If I were to go either left or right, the tiles will sort of merge together and become an 8. So they add up together and become 8. So if I go left, they become 8. Now I have two 8s together. If I do the same thing, if I go left again, they become 16, and so on and so forth. If I go down, those 2s right here become a 4. And then you can sort of figure out other ways of multiplying stuff. And eventually, ideally, hopefully, come up with the number 2048. Although it is possible to fill the board up with numbers such that it's impossible to do that. You'll notice if I make moves, random 2s spawn in different locations. And if you get it such that no moves that you make, up, down, left, or right, can combine together to form a composite number, then you've lost the game. And you get a higher score, sort of the fewer moves it takes you to achieve the number 2048. So thanks everybody for tuning in. So JP Guy said hello, Nafis, Kuning Sonk, Amandula for you, Asli of course is here, and Prakash997 and Nordic Cucumber, love the name. So for those who have not watched a game stream that I've done, what I typically like to do is there's a framework called Love2D. And this just happens to be the most comfortable dev environment that I am capable of programming in. You could do this in any number of environments. And actually, the game 2048 by default is a web game. So you could definitely implement this as JavaScript and have this as on a website or something like that. But we're going to be doing this in Love. I like Love a lot. We've done a lot of streams on Love. Check it out. I actually teach a course through CS50, Intro to Game Development, that uses Love. And I think it's a really cool way to get started with game programming. But you can go to love2d.org. You can go down here and download the version appropriate for your operating system. It's cross-platform, so it's pretty easy to get a hold of it. How many streams are usually a week, asks Jay Winnett. Usually 2 to 3. We're a little short this week. We're only doing one stream this week just due to time constraints. But 2 to 3 is the trend, and Asli actually echoed that as well in the chat there. So thanks to Asli for that. If you get the version here for your operating system, you can usually have it as some sort of executable like this on your desktop, whether you're on Linux, Windows, or Mac. And alternatively, you can also use it through the command line. So I actually have it aliased on my machine such that I can type the word love, and then it'll just run the version of Love that I have on my computer, which is 11.1. They have 11.2 available right now. Will you make it playable on Android? I will not make it playable on Android during this stream, but you can make it playable on Android as far as I've seen. I actually am not super familiar with the process of doing that, but it looks like they have an APK for 11.1 that you can download, such that you can have it work for that, and you can create a, I'm sure there's a workflow for actually creating Android-based executables for your love apps. And shout out to David in the chat. So as I said at the beginning of the stream, David teaches the course CS50 if you're unfamiliar with this ecosystem, the CS50 ecosystem. But check out youtube.com/CS50, facebook.com/CS50, and check out David's lectures on the introduction to computer science. They're excellent, in my opinion. And yeah. So this is separate from CS50, but related in that we explore topics that the course does not have time to go over. For example, the game 2048, or perhaps cybersecurity, neural networks, all sorts of things. But anyway, this is how you get Love installed on your computer. Super easy. Shout out to Adam, who's back after the last few streams, having missed them. Glad you've been working, Adam. Glad to see you tuning in for the game stuff. I know that you're taking the games course. So the game 2048 is going to be fairly simple. There are a lot of pieces to getting the final game up and running and looking polished. So within 2 to 3 hours, we'll see just how much we can bite off. Minimally, if we can have the actual moving around of tiles such that they mix together and that works, then we'll consider that a success. But there are a lot of other pieces. For example, whether the board is solvable or whether the board is full and we're incapable of making a move. That is a bit of code that might take a bit of time. Could be fairly straightforward. We'll see how we structure our code and if it's easy or not. But that might be one of the nice to have features at the end if we have some extra time. And there are other features like that that we can talk about as we get to them. So I'm going to not use a separate desktop, but I'm going to go into my streams folder. I'm going to create a new folder called 2048. And I'm just going to click and drag this down to VS Code. VS Code is an awesome text editor / micro IDE if you want to use it, and use it with a lot of its extensions depending on your programming language. There are a ton of plugins through the extension store. Here you can click on search here and get things for different languages that it doesn't ship with by default, linting, debugging capabilities, autocomplete for a lot of stuff. It's pretty cool. A lot of really cool, interesting things. We won't use too many fancy stuff, but I do have the Love 2D support plugin by Pixelbyte Studios. If you're using VS Code, highly recommend this. I can literally type Command L on my Mac, and it'll run the source code. I don't have to click and drag anything. I don't have to run anything at the command line. Super easy, super straightforward. We've talked about this in prior streams, but this is for the folks that are brand new that don't know what Love is or have never programmed using VS Code or Love 2D or Lua. Speaking of that, Lua is the actual programming language that we're going to be using. So Love 2D is the actual sort of engine, so to speak. It's a very simple sort of executable that you run, and then you load in Lua files to it. Those Lua files sort of talk to the Love executable and let you draw things to the screen, do sound effects, do movement, and all sorts of other cool things. But the language itself is Lua, and so the two are sort of extricated from one another. I'm going to go to my Explorer here, and I'm going to create a new file. And this file is going to be called main.lua. So again, we're using Lua files. Main.lua is the starting point of your application in a Love 2D project. So this is, if you're programmed in C, it's kind of like int main. Or if you've programmed in Python, this is kind of like the main module that you use to bootstrap your application, where you often will have the if __ name is equal to main. Prakash asks, using Atom instead of VS Code, and if you're asking about whether that's a good move or not, I would say they're pretty similar in functionality. It's up to you, really, if you want to use Atom or VS Code. I like VS Code a little bit better. It has a tremendous development base currently. It's got Microsoft support. Microsoft bought GitHub, so you can sort of visualize maybe how that might lead to some good things in the near future, considering how that ecosystem is sort of playing out. But VS Code is also, it seems to be a little bit lighter weight with the RAM usage and faster with opening larger files. Atom kind of chokes on that. So there are pros and cons. Certainly, I think with both of these, as opposed to Sublime, Sublime, for example, is more efficient with a lot of larger files because it's written in C++ as opposed to Electron. So it's kind of up to you. They're all sort of at feature parity for the most part, until you get into the plugin sort of thing, and then maybe some languages have better plugin support. But use whatever you enjoy using. Anyways, little minor aside there. This is going to be where we have all of our code sort of launched in our project. So I'm going to go ahead and create a little comment block up here that says 2048. I always have a habit of writing 2014 because I'm used to write, anytime I write 20 something, it's usually a date, 2019, 2000 whatever. So I might make that typo in the future. So I apologize in advance if I do. Bavik Knight, good to see you. Bavik Knight, another regular for the ages. So let's go ahead and write a few boilerplate functions here. So anybody who's watched the stream before knows all of these probably by name now, probably has them memorized. But these are all important functions that Love sort of looks for when it loads up your main.lua. And this is sort of the backbone of your game loop. So a game loop is an important thing in games. It's basically an infinite loop, sort of like a while true or a while one, where it checks for user input, then it updates the scene depending on what they've input, and then it'll draw the frames depending on what things have changed with the update. And this sort of loop of input, update, render over and over and over again, 60 times a second, is what actually looks like a game in the end. But all it really is just a sequence of still images going really fast one after the other. And the sort of juxtaposition of sounds as well, depending on what you're doing. DN SMTP hi, all CS50 lovers. I like that. So these are the functions that really define your game loop, really. So the update, of course, is the update portion, like what variables do we need to change this frame. Key pressed is what does the user press this frame, and depending on that, like what should we do? How should we change our variables? Draw is literally just what things we need to draw to the screen, and we'll look at that. And it's very simple today because all we're really drawing is boxes and numbers. And then load is sort of this function that happens right at the very beginning of the application's starting point. And this is where we can do things like love.window.setMode. And this is sort of how we can set the resolution of our window. So I can say, let's define a couple of constants here, maybe like window width is equal to 1280, window height is equal to 720. Notice that I'm capitalizing them and writing them with underscores. So these should be constant values. They shouldn't be changed. This is a programmer. This is a way of sort of signaling to the programmer in a language that doesn't have constant support, like C or even JavaScript now, to at least tell the programmer that these are constants. They should not be adjusted. They should not be changed. So I can set the mode to window width and window height. And then it also takes in extra parameters. We won't worry about that too much. And then love.keyPressed, just to make it easier on myself, I can say if the user presses the key escape, so if key is equal to escape, then love.event.quit. And so key is always going to be passed into this function every time I press a key at the keyboard. Excuse me. And a lot of these functions are sort of managed by Lua for you. You just define them and their behavior. And Love will actually determine where they actually get called underneath the hood. So this is all sort of managed for you in the C code. Actually, technically the Lua code. But a lot of the details are managed by the library itself, the engine, so to speak, itself. It's a very small engine, very lightweight engine, but you can sort of think of it as an engine. I'm going to go ahead and run this. So again, I can just press Command L and it will run the application. And it's a black window, so nothing terribly interesting, but it is the full width of my screen, 1280 pixels by 720, which is a little bit lower actually than the bottom of the window. If I press Escape, it does indeed quit the application. I don't have to go click the red X. I don't have to hit Command Q. So this is nice. We have the very sort of beginning of our application up and running. This is how I like to develop games typically, or a lot of projects, is start with the sort of minimum thing that you can possibly create, the most bare window or whatever, something that works, and then just piecemeal add things to it until it works with fancy features. And we'll start doing that here. We'll start adding piece by piece. But this is a way, I think, it helps you at least sanity check to make sure that you have things working. And especially if you're bootstrapping large projects, still adopting this philosophy will at least let you know that you're not constructing and architecting something that's going to break, or that is not nearly as close to working as you think it might be when you're in the middle of development. So I'm going to go to love.draw, and just to test to make sure that the drawing capability of the program is actually working, I'm going to do a love.graphics.rectangle. I'm going to give it the mode of fill to mean that don't draw a line rectangle, don't draw like a hollow rectangle. We're actually going to draw a filled rectangle. And I believe it takes in the x, y first, so we'll just assume that's going to be drawn at 0, 0. And we'll say that the width and height should be grid size. Grid tile size, rather. And notice that we haven't defined grid tile size just yet. It's good not to have magic numbers in your program, so I'm sort of thinking ahead a little bit. I'm going to grid tile size, make that equal to, we'll say, 100 pixels, right? And I'll run the program. And we do indeed see a white square at the top left of our window. And it is about 100 pixels wide, is exactly 100 pixels wide and tall. And this kind of signals to you how the Love 2D drawing system sort of works. So everything is based on you might have learned this in geometry or algebra, a 2D coordinate plane. So you have an x-axis, which goes horizontally, and then a y-axis, which goes vertically. And in a lot of engines and in Love, the origin point is actually the top left by default of your window. So that's 0, 0. So anything positive on the y-axis goes down, and anything positive on the x-axis goes to the right. And I'm trying to like flip this so that on the camera I'm going to the right, but in my mind it's going to the left. And so you can see that it drew 100 pixels to the right, 100 pixels down, the size of our rectangle. This applies to sizes, it applies to positions, and so on and so forth. So it's kind of flipped based on what you might have learned in school, where y positive is actually up. In Love, it's actually down. Although in Unity, if I remember correctly, y positive is actually up, and y positive or y negative is down. So it depends on your environment. This might not translate to every single 2D environment that you decide to program in. But Bavik Knight says, trying to learn the Pygame module. Recommend something else if you have it in mind. That's my first actual game dev attempt in Python. That's super awesome, Bavik. I'm happy that you're trying to program some games. Maybe some of these streams have hopefully inspired or motivated that, I'm sure. But that's awesome. Programming Minesweeper 2, which we've done on stream. So that's actually an excellent project. You have access to the source code. You can port it over to another library or another environment that you are more interested in, like Pygame or Unity or Godot or some other, all these millions of engines that are amazing. Unreal Engine also, although I'm not sure how good their 2D game stuff is. I'm sure it's good. I think they do have good sort of in-house 2D support. But anyways, many of the concepts he talks about here should be helpful in other languages too. Yep, correct. That's kind of the point that I'm trying to drill home, is that we might be doing a lot of this stuff specifically in the realm of Love, but a lot of the concepts do translate to a multitude of environments. So I encourage you to try and port things from one language to another language, and that's how you can kind of see like which things are similar and which things are not similar. And Colton's hair is asking, why are there no Twitch comments on the screen? Is it discrimination against the YouTube and Facebook guys? No, not at all. There was a glitch today that we realized right before stream that the Twitch chat wasn't working, so I apologize. I'm going to do my best to read the inspiration, I'm sorry, I'm reading the chat. Read the inspiration. Read the comments. Asley said, you're an inspiration, which is very, very nice. Thank you, Asley. I appreciate it. And I mixed my words up there a little bit. But no, I'll try to read out the comments in the chat so that we can still keep abreast of them for folks that are watching after the fact. And we'll debug why it's not showing the comments afterwards. But unfortunately, we ran out of time before the stream started, and it was not worth rebooting our whole streaming infrastructure 3 minutes in advance, and then, yeah, starting. Colin thinks you're talking to him. Yeah, except AP. You did them all, blah, blah, blah. But that was my whip streak. Oh, okay. So Asley clarified and said that the inspiration comment was meant for Nate. I apologize. I came into that conversation sort of right in the middle and was not sure what was going on. So I apologize. That did sound a little bit conceited. I did not mean for that to come across that way. So I apologize. Nate, you are an inspiration. I agree with Asley. Nate is very young, 10 years old, has completed all the CS50 courses. So shout out to Nate for his hard work. His final project was awesome, and I'm excited to see what he comes up with in the future. We've code reviewed Nate's stuff on stream too. So if you watched our code review streams, you've seen it. Anyways, not to get too off track here. We drew a rectangle, so now we can see what the rectangle looks like. We can actually see the drawing capabilities of Love. Not too fancy. Not too fancy at all. It's just a white rectangle. But this is the foundation. Like, this is essentially what we're going to be doing for our stream, right? We're going to be drawing 9 rectangles. I believe it's 9 rectangles. Correct me if I'm wrong. Unless it's 16 rectangles. Let me just confirm this. Oh, it is 16 rectangles. Thank goodness that I confirmed that, because that would have been unfortunate. Probably more difficult too. But we're going to be drawing 16 rectangles and actually a dark background as well for this sort of, back here. And actually, I think it would be nice of us to actually have a light background for the window too, just to make it look similar. So that's what we can actually do that. I can say love.graphics.clear. This is a cool function. This will actually allow you to clear the screen, to like draw over everything on the screen with some sort of background color, right? And let's find out what color this actually is. So I can use the Colors app actually on Mac. And if I go over here, and I think it's this. No, it's not that. If I go here, click on this, and then click on that, I now have the color. So it's F-A-F-A-E-E. OK, so that's cool. We can do that. Now, Love changed its version. Changed the way that it does color from 0.10.2 to 0.11. So it's a little bit different than, it's a little bit less straightforward now than it used to be. But I think it's for performance reasons. Underneath the hood, it's easier to use floating point values than it is to use integer values for colors. And Guy E. White says, how easy is it to implement a Love or Lua app in iOS? From what I understand, easy. To be fair, though, I have not dug too deeply into doing it for iOS or Android, but they have documentation on the website, and from what I've heard from people trying to get it working, it's not too hard to do. So I would definitely take a look at it. Something tells me, my gut is that it's probably easier in some ways on Android, because Android is such an open platform. You can get pretty much anything to work without too much difficulty. iOS is a little bit more closed platform. But from what I understand, there is a way to get apps working for both of them. So let's go ahead and we'll say 1.0, or rather 1111, right? So here's by default the color white, right? I believe. Yes. So now we have a white window. And the reason for that is that Love now treats colors, RGBA is what these are, red, green, blue, and alpha, as floats between 0 and 1. So 0 is like no color, and 1 is full color, right? And so if we mix all the colors together at full color, that becomes white. But if I were to, for example, say 0 for the green and blue, so again, this is red, green, blue, and alpha. If I were to make just the red component full, just 1, everything is red, right? So that's the color red. We get white by mixing all the colors together. Now, I don't want full white. I actually want this sort of off-white color. So what I can do is I can say 250 over 255, right? Basically, you can say every color, if you get your color in RGB format like this, you can essentially divide the color by 255. Or would it be 256? No, it would be 255. Is that true? Yes, it would be. So you can divide it by 255. And that'll give you the equivalent number from 0 to 1. So obviously, if 255, if it was 255, that's full white, right? We can do this here. 255 divided by 255, 255 divided by 255, and over here, same thing. 255 divided by 255. These will all equate to 1, and it will get the same exact value. And then what we can do after that is we can then look at this and say, OK, the red is 250, the green is 250, and the blue is 238. So we'll go ahead and say 250, 250, and 238. Whoops. And then now it's kind of hard to see, but we do have a slightly sort of off-white color. You can probably see the white rectangle up here that shows you the actual color difference between the background and the white rectangle. I imagine 0 to 1 would allow for almost unlimited color depth. It's a lot. So you get, I don't know what the color depth is, how many colors are theoretically possible. It's in the millions. I don't know how many millions it is. Actually, it might be, is it billions? I don't actually know offhand. How many colors in 32-bit color? Yeah, about 1.7 million with transparency. Wait, no, sorry, 16 million with transparency. So that's how many colors you get with 32-bit color, which is 8 bits per red, green, blue, and alpha channel. But yeah, this is how you would translate in an environment where your colors are based on 0 to 1. This is how you could create a mapping between integer color components. The dog in the office is howling, which is adorable. So this is how we're doing it here. And I'm actually going to get rid of this rectangle for now. And what we can do next is look at the background and maybe start drawing the background colors. Unrelated, will you ever have Jordan from the mobile dev course on a stream? I started that course and he's really good. You know, he's super busy. I would be cool to have him, but he works full time, and he's a project lead, engineering manager actually, and he's just insanely busy. So we asked him actually to be on the stream, and he said he just wouldn't have the time, and totally understandably so. So I would probably not anticipate that. Is there any tool to make the background transparent? I don't know if it's possible on Mac, Bavik. Mac makes it kind of difficult to do that. But I would do some research. That'd be interesting. Mac makes it hard to do a lot of interesting UI stuff, more so than Windows typically does. So we're going to go ahead and I want to create a rectangle that is, we'll define a few constants up here. And we'll say grid background x. We'll make that, well, first of all, let's make the width and the height. So the width should be, we can derive this from our actual window width and height. So we'll say window width divided by, you want to say divided by 2? Yeah, we can make it divided by 2. We can make it half of the window width. Grid background height should be equal to, and then this will be window height minus window height divided by 4. So it'll be 3/4 of the window height. That should suffice, I think. We'll take a look at that. We'll get a sense of it here. So if I create this as fill and love.graphics.set color equal to, let's get the colors of this right here. So this color is 186, 173, 160. Okay? So we'll say 186, 173, and 160. So 173 and 160 divided by 255, and then we'll just call that 1. We don't need this 255 divided by 255. We'll just make it 1. And then what this love.graphics.set color does is love operates kind of like a state machine. So if you tell it to set the color, there's like a global sort of marker that love has that it will use to draw things. So if I set the color to some darker gray color or whatever, like I just did, it will end up drawing everything after that in that color until you set a new color, basically. So what was the shortcut you used to get the color? The shortcut that I used to get the color. The shortcut that I used to get the color. What I'm doing here is I'm just using the Mac built-in colors thing, and then there's if you click on there's like a box that's like color select box, and in here there's a little eyedropper tool. I think that's what you're referring to. I apologize if you're referring to something else. And this is what I'm using to grab the color. So I just click on this. You can then click on anything on your screen, and that will give you the pixel value of whatever you clicked on. Now if I choose 0, 0, and what would I name them? Grid background width and height. So grid background width and grid background height. And then I run this. We now have a background that looks like it'll probably be a good size for us. It's not centered though, so let's actually center it, and let's actually also change our window title. So we'll set title to 2048. So now you can see up here, this now says 2048, just a little minor detail, minor bit of polish. And for this X and Y, what I want to do is actually make them I want to center, at least on the X axis, probably the Y axis as well, sort of where the grid is being rendered. Now the width is half of the window width itself. So it's literally half the screen. So what I can do is I can then just say window width divided by, would this work? No, this would have to be divided by 4. And if I do this, now we have it centered right in the middle. So by making it half the window width, we ended up making it, sort of half the screen size. So if I were to make this window width divided by 2, you can see that it goes straight to the right. It fills the right side of the screen, right? Because we made it half the window width. But we want it to be centered, so we actually have to subtract by half of that missing white space. So that we do that just by setting the X to window width divided by 4, right? Which ends up sort of backing it halfway, half of the half, right? Which is the quarter, and that ends up placing it right smack dab in the center of the screen. We can do the same thing with the height here. If we set this equal to, since we're making it equal to 3/4 of the window height, we want to shift it down by 1/8 of the screen. So we'll say window height divided by 8. Should work. And there's a little bit of missing white space below my window, which you can't see, but this looks about accurate to me. Do live leet code problems? Not sure what you mean, Adam. You might have to elaborate on that a little bit. Here, let me take a drink. A little bit of a dry mouth. So this is cool. We now have a sort of the background of this. We could also add this 2048 logo above where we're drawing the grid. We could do that too. But another important thing that Love lets you do, which is pretty cool, is actually specify kind of a border radius. Or rather, in this case, it's border radius if you're coming from like CSS. But this is kind of like kind of like what you get with CSS, but this is like beveling. This is beveling the edges with vertices, essentially. It's basically saying how many vertices do you want for fanning on the edges of your rectangle. So I'm going to say this. Actually, that might not be the right. That might not be the right thing here. So let me say rectangle love. Actually, well, no. We'll type love graphics rectangle. I need to figure out which of these parameters it is. Mode, X, Y, width, and height. Oh, right. It takes a rotation and then segments. That is why. So 0, 0, 0, and then 3. So now, oh, that didn't work either. Oh, I'm doing it in the color. Whoops. My bad. That is the wrong place to do it. That is why it's not working. So we'll do 0, 0, 3. Should work. Am I getting this correct? Rectangle with round core. Mode, X, Y, width, height, RX. Oh. X axis radius of each round corner. Got it. Okay. I feel like this has changed. I don't remember it being like this. But now you can see that we do indeed have rounded corners on our rectangle. So you have, it's basically we're saying how big do we want the radius of the rounding to take place. So I've made this 100 and 100. It gets a little bit larger. You can see, and you can sort of see there where that 3 actually takes place, right? We have 3 vertices, the 3 fanning segments is what they called it in the documentation for how we want our border to be laid out. I don't want it to be that big. I'm just going to use 10 pixels. and it looks like that, and that looks totally fine. Like that looks pretty well-rounded, pretty good. You can make it larger if you want to, or the segment number higher if you want to, but now we have sort of what it looks like here in the game itself, right, with the rounded corners. Now, what I want to do is I want to actually draw the set of tiles that will exist inside of that larger rectangle. So what I can do is, I'm trying to just think ahead of how I want to engineer this. A simple way to do this would be for y is equal to from 1 until 4. And let's see, do for x is equal to 1 until 4. And probably what I would want to have happen is love, or not love, it would be rectangles, no, it would be tiles. Tiles at yx render. And here's where we have to go a little bit higher level and actually start maybe making a, actually no, we're not going to do that. We're not going to do that. We're going to keep it somewhat simple. We're just going to keep all of our rectangles as tables. So if you're unfamiliar with Lua, a lot of what I'm doing has been pretty straightforward so far. It's been pretty similar to what you would see in a lot of languages like JavaScript or Python even, where you have for loops, you have variables, you have functions that you define. The function syntax is even somewhat similar to JavaScript, although it does have this end keyword, which is a little bit weird. And you see the end keyword exists for for loops as well. But the main data structure in Lua is actually the table. So now if I create this thing called tiles, you'll see that I use these sort of curly brackets that you would get for this isn't Twitch Codes 2048, boo. Twitch coding 2048 would be an undertaking, Moo9, but I appreciate it. I think that would be pretty cool. Wait, what joke are we talking about? People are saying there's a joke. I apologize. Oh, what is love? Baby don't hurt me, baby don't hurt me no more. Got it. Thank you for all the amazing humor. We get jokes for days in the Twitch chat. It might be a blessing that we don't have the actual chat live today. But no, it's pretty funny. I'm actually kind of surprised that we haven't made that joke yet. And thank you, Adam, for the more pragmatic definition. Love is an intense feeling of deep affection. I agree. Twitch Codes Fortnite would be more up our alley. Yeah, Twitch Codes Fortnite. That would be with a release date of like 3500 AD. But I digress. Pip install 2048. Yes, there we go. Amazing, amazing. What I was getting at was in Lua, the main data structure is called a table. And a table is essentially what you get in Python with dictionaries, even in C with arrays. It's similar to arrays, although they're dynamic, so they're not, you don't have to worry about memory management with them like you do in C. They're similar to JavaScript objects. They're like a multi-purpose data structure. They're actually kind of similar to how PHP does its arrays, if you've programmed in PHP. And what we can do is we can say, OK, what we're going to need is this sort of 2D matrix of tiles, right? We're going to need to render tiles this way and this way. There's going to be 16 of them. They're going to have a Y position and an X position. Irene, hello, good to see you in the chat. But essentially, we're going to need a way to store all of these tiles in some sort of matrix. And that's why we can use a table, and specifically a 2D table, to do this. Now, what I'm going to do is I'm going to create an empty tiles table here. And in a loop, I'm going to say for y is equal to 1 until 4 do. And this is sort of magic number-y, but bear with me here. Table.insert into tiles another table. Now, this function, table.insert, is the way that you add things to tables in Lua. It's sort of like the append in Python. It uses literally the word table, which is sort of like a namespace that contains all of the table functions. And table.insert just lets you add something, whatever you want, into an existing table, which is why we're passing in tiles here as the table that we're going to insert to, right? And this is going to get I'm thinking now, we're going to want essentially a couple of things. we're going to want a 2D table that we can keep track of tiles in their grid space, but also we're going to start tweening tiles together. So because of that, things are going to be moving asynchronously a little bit and moving around. They're going to have independent sort of x and y values, but what we can do is we can still assign them, I guess, a grid space. So we can say, we'll give it an actual x value. So its x value is going to be equal to we don't have it laid out as a simple variable yet, but we could say something like wherever we start drawing this. So window width divided by 4 as the x. We can use that as our starting point. So yeah, that would be our starting point for the x. So sorry, window width divided by 4. This would be window width divided by 4 plus, and then this would be, and this is kind of where it gets a little bit messy because we actually have this x value, and then we have this x in this upper loop, which is where we're actually keeping track of the number of x tiles that we're creating. But I can say x minus 1 times grid tile size, like that. And so what this will do is if x is 0, it will just add it at window width divided by 4 plus 0. Or sorry, if x is 1, this will be equal to 0 times grid tile size, which is 0. But if x is equal to 1 up, or 2 up here, so if it's the second tile, we can end up having this will end up being 1. So it'll be shifted over by window width divided by 4 plus an extra, whatever the 100 pixels, which is whatever the grid tile size is. We can do the same thing for y. So I can say window height divided by 8 plus y minus 1 times grid tile size. We'll get the same sort of thing. And now if I end up going down here, we're not going to create a render, but what I can say is love.graphics.rectangle on tiles at yx. Oh, actually, this is another thing that we're missing. Table.insert into tiles a new table. So if we want to have this 2D table where we have a matrix y and x, then we need to basically have a table of tables, right? So eventually we're going to have tiles looking like this, where we have a table with all these tiles within them, right? And then another row with all these tiles in them. But these parent tables, right, these outer parentheses within inside this table need to be added to the table itself. So this is why we're doing this. This is why we're table inserting an empty table for every y. For every y is this, right? Because we're looking downwards, right? So I'm going to delete that. And then I can go ahead and I can say table.insert tiles at y, not at tiles itself. So now we're adding into the nested table. And so now we have this ability to go tiles yx anywhere because we have a 2D table now. We have a table of tables. Within each of those tables are the tiles themselves, which is going to have their x, y data, their number data eventually. So all pretty important stuff. Now, let's go ahead and draw them out. So this needs to be fill. And actually, what I'm going to need to do is set the color. Well, eventually, they might even need their own color changed as well. So eventually, this is going to say love.graphics.setColor tiles yx .color. But we don't have that as a field yet. So what we're going to do instead is I'm going to use color picker again. And I'm going to go back to 2048. And I'm just going to grab this color here, which 238, 228, 218. Sorry, 238, 228, 218. Whoops. So we'll say 238, 228, 218. It's actually, it's by tens. I didn't even realize that. 228, 218, 1. And remember, these have to be divided by 255. so that they get translated into a floating point value between 0 and 1. Again, I recommend playing What is Love in the background of the stream. It's hilarious. You know, we got blacklisted for having the that Rickroll on the last stream. So I'm very hesitant to play any audio that's not ours. But now we can say, Phil, this is going to get an x and a y. So this is actually, we can do .x tells y x dot y. And then, again, this can just be grid tile size, or whatever it is. Yep, grid tile size. And grid tile size. Oh, I have a dot somewhere that I shouldn't. Oh, whoops, I put a slash there on accident. So now we do indeed have a sort of matrix of tables, or of tiles, right? So yeah, we only played about 15 seconds of it, but that was enough to get blacklisted, unfortunately. So was quite tragic. OK. Do I have this correct here? I do, right? X, Y. And then this gets, yep, plus the grid tile size. Now, you'll notice that everything is sort of scrunched together because we don't actually have any padding for our squares, which is unfortunate. We're gonna want a little bit of that. And actually, this is also a function of the fact that we haven't really considered how our padding should translate to the grid size that we chose. We chose kind of an arbitrary grid size. What we should actually have done is, well, what we should do is figure out the tile size that we need and the padding that we need. So what I'm going to do is I'm going to also add to the padding or rather to the x and the y, sort of a padding amount in pixels that they should be drawn by. So what I can do is I can say x minus 1 times padding, right? And the padding is going to be, we'll make that 30. And then plus y minus 1 times padding. This should work, if I'm not mistaken. And it does indeed. So now you can see that we have our tiles sort of laid out a little bit. Now they're off-center, unfortunately, because our actual grid itself isn't the right size. So we can work on this. Excuse me. Yeah, we can work on this. But we have it currently working pretty well in the meantime. Another thing that we can do, just to give it a little bit more polish, is make this 553 to have those also be rounded. So you'll notice that these are now rounded as well. They're not quite as well rounded, so I'm actually going to make them 10, 10, 3, just like everything else. Is that too much rounding? That might be too much rounding. Let's see. Nah, it's too much rounding. Yeah, this needs to be 553. That's better. Cool. Everything looks pretty good so far. Everything's working. Now, when the tile does not have a color, or a number, it's this sort of grayish color. And when it does have a number, a 2, it's this color. And when it's a 4, it has this color. And an 8, it's this color. A 16, another color. 32, 64, 128, 256, 512, 1024, 2048. All of them have different colors. So we need to take that into consideration. But a simple version of this game might be just write the number on the tile and not worry too much about the actual color of everything. We're depending on its number, right? Like that might not be super important for version 1, right? So in here, we can sort of start to think about maybe giving our tiles numbers, right? But we probably also want to give it an active flag. So if I move these, you can see that the tiles sort of get moved, like the blank tiles sort of get shifted, right? So this is kind of important. And what really happens is they don't get shifted as much as you have a background being rendered with your with a flat grid, and then you have the actual numbers with the colors being rendered on top of that, and those have the actual movement. So that's the more easy way of thinking about solving the game, actually rendering the game and modeling it. So what we can do there is this will be sort of for the background. So let's go ahead and get another color for this. So may sample this color, which is 205, 192, 181. So 205 was 192, 181, right? 192, 181. Those are the background tiles now, so we'll leave those in place. Let's make the tiles a little bit larger, maybe, and let's make this square so that it actually fits. Let's see. Let's make the tiles. Let's make the grids, the tile size like 150. Let's just see what that looks like. Okay, a little bit too big. Let's make that maybe 124. It's getting better. It's a little bit too tall. A little bit too tall, yeah. So what we could do is we could make it smaller and center it in a bit more. I don't want to spend too much time like fine-tuning the actual layout of everything. So let's do a 112. That's better. Actually, we could do that. We could cheat for now. If I make the background width actually window width divided by 2 minus like 120. Let's see, does that actually work? I'll make 110. 100. It's a little bit too close. And actually, what we need to do is we should have padding plus that. So that way it actually starts based on the left a little bit. Same thing with this. Padding plus that. So it starts a little bit inwards. And let's actually make the width minus 60. Minus 40. Close enough. Same thing with the height. So we'll make the height, actually we need to make the height taller. So I need to say like plus 60. Yeah. We can cheat with this. This will work. We'll let this be our baseline to work off of, and then we can think of other stuff. It never works for me. Colton is genius at this. No, not genius. I am just messing with the stuff for the sake of speed, trying to make sure that we actually can get somewhere with this without going too crazy with the actual math and getting this to work properly. The way that this would work properly is we would shrink the overall dimensions and make this a function of window width divided by 3, probably, not window width divided by 2. And then that way it'd be a third of the size, it'd be centered, the height wouldn't be so far down, and it would be a little bit smaller looking overall. But you know, it worked. All right, interesting. So we have tiles now. They look okay. They look pretty good, right? We're right in the center, roughly. I mean, it's not perfect. You can tell it's not perfect because, see, this number is not quite above here. So that's why we would need to shift this a little bit more. But for the sake of, again, for the sake of speed, we're taking a few shortcuts here. Let's go ahead now and have, this is our actual grid, like our background grid, right? Now what we want to do is we want to actually have a like moving tiles table. And let's rename this actually. Let's call this grid. And then this will be, we'll say this is going to be draw grid. This is going to have grid. This should still work. Perfect. And then now what we're going to do is tiles is going to be something different. So tiles is going to be another table. And I'm just going to insert one tile one tile into tiles. And it's going to just be a do I want to have this be a we're going to have an issue where we need to check for tiles that we're moving to. And basically, whenever we reach another number, we want to perform that math check. Like, are we the same number? Can I mix the two numbers together and then add them and create a new tile? And so there's that process that goes into place. And also tweening, that also takes place. And we're going to look at tweening, actually. I might as well add that library while we're thinking about it, which is, do I want this to be, which library was this in? We should have used this, right? The timer library. Did we use it in tic-tac-toe? No. Typing game? Yeah, we did. Yeah, knife.timer, perfectly. So we're going to use the knife library, and we're going to put that into the 2048 folder. So if you're unfamiliar with, whoops, that is not what I meant to do. Dev streams 2048. Paste that in. So if you're not familiar with the knife library, it's super nice. It's specifically for Lua, so Life2D knife. There's a page here for it, but the actual GitHub page link for it is right here. So Airstruck knife is what it is. It's going to take a second. It's super cool. A lot of really cool modules for development in all sorts of different ways. Timer is what I like to use for tweening operations. So we'll see what tweening means when we actually get into the moving of the tiles, the smooth movement of the tiles in just a little bit. But we're going to be using it for that. It's going to be used for like generic timers, for countdowns and things like that as well. But there is a lot of cool stuff. And yes, Trucanese, we have been coding for a little bit. We have a grid like this here for 2048. And we talked about what 2048 is. And we're just about getting into the point where we create tiles that we can move around that have a number and a color. But the number will probably come first, and we'll move the numbers around and combine them before we think about colors, if we have time. It's hard to say. Hard to say if we even have time to get into colorization, but we'll do what we can do. So table.insert tiles. We can add a new tile. So let's add a tile at the top left. And then let's give us the ability to move it to the right, down, left, and up before we start adding more tiles to the list. Benzinul, are you doing chat codes Python this week? We are not doing it this week, unfortunately. We do not have. We were going to potentially do another stream. We ran out of time for doing that. So next week probably is where we'll get another chat codes Python stream. So let's go ahead and add a table here. I'm going to set the x equal to. I kind of want to keep a grid position as well. So let's say tile x is going to be equal to 1. Tile y is going to be equal to 1. X is going to be equal to whatever the first grid tile is. So we'll say, we'll say grid at y, x, or rather at 1, 1. That x, and then the grid at 1, 1 dot y. And then we don't need to keep track of a width or a height. We'll have access to that. We will give it a number. So we'll say num is equal to 2. And down here, we want to actually draw tiles. So this is where we're going to kind of need to loop through our tiles table and say, OK, for every k, which stands for key, and tile in pairs of tiles, what I want to do is love.graphics.rectangle at, we're going to make it a fill rectangle. I'm going to want this to be the actual color that we chose before. So I'm going to need that again. So if I go over to 2048 website, this, go to colors, grab this thing, go over here. 238, 228, 218. Right, by tens. So we're going to love.graphics.setColor of 238, 228, 218, 1. And remember, these have to be divided by 255. And then this will be set at tile.x, tile.y, grid tile size, 0, 10, 10, 3 for the rounding of the corners. Is this going to work? Bad argument to rectangle, number expected got nil at, oh, I see. Pairs of tiles. Oh, does the tile not have an x? It should, right? Because the grid is going to have, these are going to have x's. Num is equal to 2, right? Inserting into tiles. Well, let's go ahead and confirm that we're getting an actual tile. So if I go to the command line and I run so this, okay, so it is a table. Okay, so tile.x then, in this case, which is getting, okay, so it is getting nil for some reason. Okay, so why is it getting nil? That is weird. That is interesting. We do have the tiles here. We are inserting into tiles a new table within which is a, oh, that's why. I was enclosing it in in another table for some reason. I'm not sure why I was doing that, but now it's still not working. Okay. So we fixed that bug. Table.insert into tiles. Another, okay, so tile x, tile y, x, which is equal to grid11.x. So is grid11.x not actually getting anything? It should. It has to be, because we're already rendering the grid. So we know the grid is getting all the x's and y's. Also, welcome to debugging. So hopefully you all don't mind this too much. This is good stuff. Reading some of the funny messages in the chat that they don't want to make necessarily public. Okay, so we're very clearly creating a grid of tiles. And another thing that we're going to also want to do so that we can very easily check, we can very easily sort of check which tiles are where, like which tiles are empty, which one, like so that we can move things all the way to one side or meld things together, is we're going to need to add a field to each grid tile that says occupied, whether that's true or false. We'll set that to true now. It doesn't matter yet. We're not actually using it, but we will use it in the future. That's essentially going to be a flag that basically we're going to use to say whenever we move all the tiles, we're going to go, if we press left, for example, we start all the way on the right, we work our way left, and we check, is the tile to the left occupied? If it is, then, well, actually, is it better to move, is it better to work from left to right in that case rather than right to left? It might be better to work actually the opposite direction, left to right, such that we can say, we can look for an empty tile or leave the tile as is if it's occupied, and then work our way to the other end. That's probably what we'll end up doing. That seems like it makes more sense. But in the meantime, I'm going to figure out why we have this weird XY bug. We very clearly are setting X and Y. Oh, wait, that's Y. Y is equal to. There we go. Okay, figured it out. I forgot to say y is equal to grid11.y. That's a very important step in creating a table if you want your keys to be accessible, is to actually set the key. Okay, cool, excellent. Now what we also want to do is say love.graphics.print, and then we want to do is we want to say tile.num at tile.x, tile.y, and then actually this is going to be a printf, and what we're going to do is we're going to say tile.num, and then this is going to be the starting point is going to be at x and y, or rather y. Well, this could be a little bit trickier. This needs to be tile y plus tile y plus grid tile size divided by 2, probably. Minus the size of the font, but we'll worry about that in a second, because we're going to create a new font to actually use it. And then what we're going to do is we're going to need to, since we're using printf, this is actually a center print operation. So we have what we want to print, which is the number right here, tile.num. I believe we set that to num, right? Yep, num is equal to 2. And we want to start drawing at x, the tile's x. We want to roughly draw it halfway down the tile as well. And then we want to center it along some width, which is going to be grid tile size. And then it's going to be a center print format operation. And so now, because I think that needs to be, we need to also set the color correctly. Love.graphics.setColor. We'll use the color that they use in the actual website as well, which is sort of like this dark gray color. So let's go ahead, copy that over here. 119, 110, 101. 119, 110, 101. Again, over 255. If you don't do the 255, it'll be just pure white, because anything over 1 is the same thing as 1. And then now, you get very tiny. You can see it, very tiny little 2 right there. Super small, but we're drawing it. It's working. Oh, yeah, and Cerule CS for y equals is missing. I appreciate that. Thank you for the thing there. I probably missed when you said it initially. Let's go ahead and do one other thing. So what I want to do is I want to say font is equal to love.graphics.new font. And I want this to be 32. And then I want to say love.graphics.setFont to font. Now what that should do is make the number bigger, which it did indeed do, which is nice. Ekaterina, is it possible to add translated subtitles to a CS50 video on YouTube or not? I still have nothing better to do. Sad, crying Isaac face. Let me chat with David. I'm not sure. A lot of people do volunteer to do that, and unfortunately, it turns out that usually people get kind of disillusioned and stop doing it after a certain period of time. We've started contracting with companies to do it, but let me see. That might be something worth looking into. Let's go ahead and, for when we actually printf, like I alluded to earlier, this bit here, where we sort of add the y offset, I'm going to say plus font get height divided by 2. Now that should work. Oh, sorry, minus font get height divided by 2. And there we go. Now it's perfectly centered right in the middle of the tile. Now it doesn't quite look as good as it should, so what we can do instead is say this font should be 64 pixels. And now that looks a little bit better. Now it's kind of starting to look a bit closer to the actual game. Unfortunately, we don't have the ability to move our tiles. So what we can then do instead is in our key pressed, we'll say if key is equal to up, else if key is equal to down, else if key is equal to right, else if key is equal to left. And this is where we can sort of think about moving the tiles as an aggregate. And right now we only have one tile to move around, but this is sort of a perfect illustration of where we should go, right? So if the key should be moved, if we press the key up, all the tiles should be moved up. So for k tile in pairs of tiles, do, and then this will be, so they should be moved all the way down, left, right, or up, depending on where they are. So right now we can just do a naive bulk move everything at once, which will have the effect of sort of pushing everything to one edge and not like actually stacking things. So we'll do the naive approach first, and then we'll work our way towards a better and engineered approach to it. Yeah, we will detect collision, Bavik. That will be at the next iteration. Right now, we just want to get all the pieces in place and build things up piecemeal. So let's go ahead and say tile dot in this case, tile.tilex is going to be equal to 1, or rather, tile.tilex is not going to change. Tile.tiley is going to be equal to 1. And therefore, we want to adjust the math here. So we can use this same thing, which is a sort of x calculation, or I guess a y calculation is what we care about. But what we want to do, well, actually, no, we don't even need to, well, we can use the existing grid numbers, actually. Those have already been pre-calculated. We don't even need to, we don't need to worry about them. So what we can instead do is say tile yx, or rather tile.x is equal to grid at, what would this be? This would be tile.tiley, tile.tilex is equal to, or that's what it is, right? .x. And then tile.y is equal to grid at tile.tiley, tile.tilex.y. Perfect. That will work for all of these. And again, this isn't the most well engineered, just because actually bootstrapping this into a large application would probably take like 3 or 4 streams. So we're just trying to get as much done as possible. And I can't even promise that we'll have, I'm hoping that we have the whole thing done by 1 stream, by 3 hours or so. But we'll see what we can get. We'll see what we can get going based on not having to engineer things quite as crazily, right? So for down, it's kind of the same thing, but this becomes 4. For x, this becomes tile x, not tile y, and that becomes 4. And then this becomes tile x, and that becomes 1. Perfect. So if everything goes according to plan, I can now move this tile from one edge to the other edge, right? So this is pretty good. This is pretty good. Now, if I want to add another tile, so let's say I go over here and I add another tile here. Well, actually, whoops, not what I meant to do. This needs to be another line. And we'll do this. And then let's say at this I want it to be, this I want to be at 2, right? And then the x can be set to, well, it's 1, 2 in this case. Voice crack. 1, 2, there we go. So now if I move to the right, so I can move them up and down like this, and it's totally fine. But if I move them to the right, notice that they all collapse. And that's the problem that we're trying to avoid, is that collapsing of the numbers. So what we can do there is, it has to get a little bit fancier. Now we sort of have to say, we have to have a loop that sort of works backwards from whichever direction we are writing or we are pressing the key from. So if we're pressing right, we need to work our way backwards from the right and basically look for a tile with that at that grid index that's there and move it as far to the right as it can go. And then from that position, we work our way to the left and then do the same thing, going as far right as we can go. And if we switch basically that tile that was there and we say that now instead of the tile, let's say we have this tile here and we press right, we go to the right. And let's say there's two tiles here. We click this tile here. We remove this tile being claimed from the grid. We basically say to the grid, like, there's no tile here anymore. There's going to be a grid. The tile is going to be moved here. So now, if we move over to this tile and we look from left to right for the first available empty tile, it's going to be, or the last available empty tile. It's not going to be this one because this one's taken. It's going to be this one, right? Looks like Love crashed, I think, because I clicked on it. So that's my bad. Give me just one brief second here. The entire world is sending me messages at the moment. But no, this is cool. Can a stack be useful here to implement? If the latest two pops are equal, add them, else not. If the latest two pops are equal, add them, else not. I'm not entirely sure, Bavik. I'm sure you could probably find a way to get a stack to work if you wanted to. There's probably infinite ways to get this to work, honestly. I'm not sure. But I would encourage you, if you do have an idea for wanting to program it that way, definitely try and give it a shot, see if it's more elegant of a solution. This isn't going to be the most elegant solution. This is going to be kind of thrown together for the sake of getting this done, as soon as we can. But a more well-engineered way would be to have in a class hierarchy where, well, not really a hierarchy, but really a model for our tile. That tile can move around, interact with other tiles that exist on the grid, and yeah, really that's ultimately what it would be. And probably a lot more functions than what we have now. Currently this is, I mean, it's not bad so far. We're still at roughly 100 lines, and we have some functionality. But we could have, I am very well aware this could be well engineered in many other ways. But we will try, we will get it thrown together the way we can in this stream, and then maybe we could talk about it in another stream later. Unfortunately, we don't have that much time for streams. I wish we had more time. If we had like 8 hours, we could sit down and like super comfortably just make this beautiful and bootstrap it. But unfortunately, we do not have that time. OK, so let's actually get it so where we can move the tiles, but they don't stack on top of each other, right? Like that is super important. So let's go ahead and do that. It's going to be sort of a loop, which says, and now we could make a function for it, but let's work on our down first. Actually, you know what? Let's do right first so that we know that it's working for our immediate use case, and then we can try left, and we can do left as well, and then up and down. It'll be pretty easy to do the rest of them. So we'll see how that works. So we'll do down, or we'll do right. So this is going through the tiles one by one and basically setting their x to 4. But obviously, that can't work. But what we could do is we could say, we could have a function called get nearest open x that takes a start and a finish, right? And we'll take the start as tile.tilex and the finish as well, another thing that we need to worry about is this needs to operate right to left. But this will potentially work. So we'll say function get nearest open x, and we'll take a start and an end. and we'll say for x is equal to 1, rather start, end, do. Oh, right, we can't do end. That's a keyword. Start, finish. Whoops. So from x until the start, from the start until the finish, what we want to do is we want to say if grid well, actually, it shouldn't even be nearest open x. This should be get farthest open x, right? I feel like that's probably more what we're looking for. So what we do then is we say farthest open x. And then if grid at, well, I guess y, we need the y as well, actually, I'm realizing. So start x, start y, finish. So this will be tile.tile x, tile.tile y, and then we want the finish, which is, in this case, 4. We want it to be the end, right? Because if we're going to the right, then we want to check to see how far along on the right we can get. So we'll say if grid at tile, or rather at start y and x dot, or rather occupied. So this is what we need to do. We need to say if it is occupied, right? If we found a tile that's occupied, or rather, in this case, we would return finish, right? If the grid at y, x from start to finish is occupied, then we need to return whatever the one before it was. So we just say return x minus 1. In this case, math dot, we need to return, we need to make sure it doesn't go, we need to make sure it's not 0. Because if we start at 1, and let's say 1 is already taken, or, well, in this case, well, we are going to 2. No, but we are starting. So we actually, what we need to do is we need to actually start, here we go, start x plus 1, right? There we go. And then we just return x. I think. Yeah, I think that's the case. And then this allows us to decide like which tile can we get to at the end that is open, the nearest one at the end that's open. And as a part of this, we could actually also set that tile to occupied, which you probably want to do. So in this case, what we would do is we would say grid at tile.tile y, tile.tile x is dot occupied is equal to true. And then this occupied is equal to true is basically in the grid, like where x and tile x, that's a good question, says userman. That's going to be for when we start tweening the position of the tile, like when it's moving. So right now, this might be broken, actually. No, it's not. But if we move up and down, you see that everything moves immediately. But we want things to move sort of over time, like using a tween operation. And in order to do that, we can't tween the grid position because those are discrete. Right? There's not a floating point sort of grid position. You know, this is grid position 1, 2, 3, and 4 on the y-axis, and this is 1, 2, 3, and 4 on the x-axis. We don't actually have the ability to draw their position sort of discretely like that, or continuously like that when we're using the grid. So we keep a separate x, y for where we actually draw it, for where we actually render it, so that we can tween this down to here smoothly, because that's where we're actually rendering it, right? This tile y is specifically used just for keeping track of where tiles are in the grid, and the x and y are used for rendering. And we could illustrate this if I do a tween operation. If I say timer.tween of, let's say 0.2, and then tile is going to be equal to x getting the value of this, and y getting the value of this. This is ultimately what we're going to transition to. And what we need to do first is actually require the timer library. So I can say timer is equal to require lib/knife.timer. So again, we added this knife directory here. Dot in Lua just indexes into this folder. So it's kind of like going into a folder. And then if we say timer, it just grabs the timer.lua file. It doesn't need the .lua extension in order for that to work. So we have the timer library, an important step. And we've talked about some of this on prior streams, which is why I'm sort of going kind of quickly. We need to actually update the timer every frame for this to take place. Now what we can do is, and are we re-rendering the tile X correctly, right? Yes, we are. Cool, awesome. So that should work. That should work totally fine. This is a tween operation. A tween just means move something continuously over time. So this is what we're doing here. We essentially just replaced what we had with this sort of odd syntax. So the tween function sort of takes in like, what object do you want to tween the properties of? In this case, the tile. We want to tween the tile's properties. So OK, so let's tween the x value over to this eventual value. So whatever its current x is, after this value of time, 0.2 seconds, so after 0.2 seconds have elapsed, I want x to equal this. I want x to equal the new tile y tile x dot x value, right? Which, at the grid value. And that's why we're keeping track of our tile y and tile x. We can multiply effectively that value by our x. Or actually, well, we don't even need to do that because we already did that. But we can index the grid's x and y because we pre-multiplied all of that up here, right? We did this operation which created the grid, which multiplied sort of the 1 to 4 into this mapping of, tile grid size plus window width divided by 4 plus padding value, all that fun stuff, right? So now lib_knife.timer is not found. Oh, right, because I just added it as knife. Let's create a new folder. Can't create a new folder for some reason. Lib, and then knife is going to go into lib. And now we can run it. So now if I move them down, notice that they tweened. They didn't move instantly, but their x and y were interpolated, which is a crucial part of sort of the fun sort of flow of the game, right? Because the way that makes it feel good and responsive. It's a little slow though. I noticed it felt a little jittery. So I'm actually going to increase that speed to 0.1. See how that works. There we go. That's pretty good. We do the same exact thing with all of these other ones. So I can say, we'll do this here. This here. And this here. Cool. So now I can move them. This is interesting. It's not moving them all the way. We have some interesting bugs so far. Moving to the right only moves them one tile at a time. I think because to the right why did we do this? Oh, because we have the get farthest open x returning. In this case, it's actually interesting. Oh, because we're setting occupied to true as a default. We don't want to do that. We want to set occupied to false as a default. There we go. Now we can move left, right, up, and down pretty smoothly. the game's sort of foundation has been laid effectively, which is pretty nice. Now, I'm going to create a GitHub repo for this right now and start committing stuff. So if you all want to follow along, you're more than welcome to do that. Just because we're at a pretty major working piece here, which is cool. I already have GitHub open over here, actually. Oh, well. Let's do this. Wait for GitHub to load. It's a little bit slow. They are features, says Bavik. Yes. In a sick, sort of weird way, you could sort of think of them as features, too. This will be 2048 stream. Live stream, where we implement this sliding tile game 2048. This will be public. Let's go ahead and do this. Boom. Git init, git add dot, git commit everything. OK. Cool. So it should work now. So it comes with knife and it comes with main. So now you can go to github.com/coltonoscopy/2048 stream. Oops, I misspelled that. Sorry, don't type that, or don't click on that. I told you I was going to make that mistake, and I did. There we go. Click that second link. That link is good. Yeah, for some reason, every time I type 20, I want to type a 1 because it's always 2019 or 2018 or whatever that I type. So it's just become part of my muscle memory. 2048 it throws a wrench into that a little bit. But yeah, you can see where we're going so far, right? Made some pretty good progress. So the next major piece that we want to do is we want to prevent the collapse of the numbers onto one another, right? So in order to do that, let's work our way backwards. So where do we actually create the tiles? We do it here, right? So what we need to do is we need to set the grid to occupied at that particular place. So what we could do is we could make a function that does this. Might be a little easier. But for now, let's write it out in just up here at the very top. We'll say grid at this will be 1, 1, right? So 1, 1 dot occupied is equal to true. And we're going to do the same thing for this, but this is at 1, 2, right? And so now, ideally, add mock tiles. The actual core of the game, this happens randomly. So this sort of happens over time. Like this will happen every time you move. You'll just get a random tile on the grid will be set to 2. It's always 2 from the very beginning, such that you sort of have to build it back up and grow it, make it be turn into a 4 and an 8 and a 16 and a 32 and so on and so forth. Choco Kid says, just came to say hi. I have to watch it on YouTube. Gotta go. I'm so sorry, Choco Kid. So sad. Hope to see you again in the near future. Maybe a function to map the tile X, tile Y to position of the tile in the list. Oh, do tiles pop up as 4 as well, Andre? I thought they were only 2s, as of the documentation that I just read. I very well could have misread. To be fair, I only read the documentation once, and I played, and it seemed like it was always 2s that were popping up, and I thought I had never seen a 4 pop up. Well, anyways. So what we need to do is, essentially what I want to do, I want to take these out into functions probably. So I'm going to say move up like this. So we'll just make a few functions here just to clean it up just a little tiny bit. So move up, move right, oops, move down, move left, and move right. And these are going to have more features in them, which is why it's important, I think, that we make it we make them functions as opposed to just putting this all inside of the key pressed callback. It's going to get a little bit weighted. Plus, this only real goal of the key press function is to keep track of the actual key input. So the more of that we can just keep in here and actually delegate the functionality somewhere else, probably better for us, easier to manage. Bavik says, if you haven't seen 4, probably haven't played enough. True, I've only played it for a couple weeks, just as I was learning about how the game works before the stream. So that is a valid point, definitely. I'm going to go ahead and set this to move down. This will be move right. And this will be move left. Hopefully the sounds from outside aren't too loud. It sounds like doing construction or something. So this is a lot simpler to look at, right? Now we're not looking at this monolithic piece of code, this monolithic function. Break it down into smaller functions. Always usually a good thing to do. So let's see. Let's tackle moving right, because moving right is, again, the first thing we have access to help us out a little bit. Wonder if someone has done analysis on the max score possible for this one. Hard to say. Yeah, that's a good question. I'm actually not sure. All right. So getting the farthest open x, right, is good. What we need to do is then say grid, right, occupied is true, which we're doing. The thing is that we are doing this in order of the tiles in the table. But what we want to do and I think this is to what Sarul was mentioning before. We want to actually have a mapping of tiles in the grid so that we can iterate backwards, because we do want to iterate backwards, checking for empty tiles so that we can move, especially when there's like gaps in your rows, for example. Like say you have a 2, a space, then a 4, and you move them all to the side. Like you need to move your way backwards so you don't try and move everything all the way to the right, right? You need to move things backwards, figure out how many tiles exist all the way on the right, and then just shuffle everything over. So we could do that. I mean, we could have a grid. We could have a grid. We could have it map in the actual grid itself. We could have the grid maintain a reference to its tile within, like the where is it? Up here. Occupied is equal to false. Tile is equal to nil, for example, right? And then this tile could be added to the grid itself. So this is what Sarul was saying, because this is going to be difficult for us to, especially as things shuffle around and move around, to actually index into our matrix in a way that is semantically meaningful, left to right, up or down, because right, it's going to always be in a random order. It's not going to be ordered at all, because we're just adding tiles with, you know, arbitrary y and x values, especially when we start getting into tiles being added randomly each turn, right? So this is an important consideration. So what we could do then is say grid tile dot tile y tile dot tile x dot tile is equal to tile, right? This would set the tile at that grid point to be equal to the tile. And then now we can search through the grid for tiles. And also this will be helpful for checking their numbers too, because we won't want to do this when we have collisions. We will want to check them to be the same number, because if they collide and they're the same number, they should stack and become a new tile, or at least one tile should be set to nil in the I guess wherever the current tile is, it should be set to nil. And then the incoming tile should be set to the new value, or at least after the tween is finished, should be set to the new value. Yeah. And actually, another thing that we want to do too is we don't want to be able to move if we're in the middle of tweening. So we can make that like right now. If I were to run this, if I were to go like that, you can see there's some glitchiness. Like I can hit down left. Oh, you see I moved diagonally, right? I should not be able to do that. See if I can do it again. Yep, see I was able to do it by pressing up and down and left fast enough. I was able to move diagonally. There we go. It's a little bit tricky. It's also setting tiles equal to occupied. But we want to avoid this being possible. I want to shut off input when I'm moving. So I can say if can move, then do all this stuff. Right? This is just a flag. Pretty simple. But the, and let's set this in load actually. Right up, where is load? Right here. Can move is equal to true. Right? If I move any of these things, then I want to say can move is equal to false, right, in all of these. And I want to add a finish clause or a finish declaration at the end of the tween operation that says can move is equal to true. So this is a cool feature of the timer library in that you can set a bit of code to execute as soon as the timer is finished tweening. So I could say, OK, once the block is finished, once this thing has all been done, execute this block of code, which means just set can move to true. So very simple. So I'm going to do that. I'm going to go over here. Boom, boom, and boom. And now what I can if I try to move two things at once, which is it's causing some weird behavior. Like it'll do it if I do it fast. Rather, if I do it like kind of fast, it'll still execute as soon as I get to that tile. But I can no longer do diagonal stuff. Like it's impossible because it's not letting me actually click on things. It's not actually letting me process input. There's like this off switch that's always off. If can move is false, then obviously I can't do anything here because can move will be false when I actually go to check for input. So this is a nice thing to do. Prevent us from doing weird graphical glitchy stuff. Keep the movement discrete, which is the nature of the game. So again, we still have to worry about the collapsing of our numbers. Not ideal, right? And another thing that we need to keep in mind too is when we move a tile from one end to another, and we set the other tile to nil from where we came from, we need to also set occupied to false. So that way we reopen up tiles that were already occupied at one point, but now our space is on the grid. My internet went off. Is it going to be available on GitHub? It already is available on GitHub, actually. We created a repo. So Bavik kindly tossed it in the stream there. That is the first working version, not including numbers working together very well. But it does have tweening tiles moving around and stuff like that. Now we're getting into the phase of the stream where we want to stack numbers. So this is important. So let's work on this. So we'll do right first. And oh, this is where we came from. This is how we arrived at this need to do this. So we're going to need to consult the grid now. Now that we're using occupied as true, right? Where is move right? So what we do now, instead of iterating through all of these tiles, which we still need to do, we need to iterate row by row over the entire grid, one at a time. So I say for y is equal to 1 until 4 do. It doesn't really matter. It's throughout the entire grid. Iterate. I have been doing horrible with the comments. Row by row over the grid, right to left. And this is the important part. This is where we're going to say for x is equal to 4 until 1 do, right? Because we're working backwards. We want to check to see if the tile is empty or if it's a tile. And if it is, we're going to move it to the right, right? But if it's a space, then if it's a, well, I guess it wouldn't really, I guess it would matter. Would it matter, technically speaking? Regardless of whether we moved it left or right? I think it would. Yeah, because we need to flag the right occupied tiles as we go along. Yeah, that's why we do. That's why we're doing it, right to left. So we basically say if we're starting at 4, for example. So this is important then. We actually need to we start from 3 because we don't care about 1. We don't care about 4. 4 is not going to move to the right. We don't care about that. We only care about 3 and farther to the left. So we're shortcutting this a little bit. So we'll say for x is equal to 3 to 1, do and then here is where it gets interesting. So this is where we actually need to set the tile as far to the right as it can go. Yeah. So we'll say tile.tilex. Or rather, we're not getting the tile here. So what we're going to say is local tile is going to be equal to the grid at yx dot tile. So this is going to be the tile itself, if it has a tile. And then we'll say if tile, right? Because we only need to move tile if it exists. If it's nil, if this is nil, if there's no tile there, then we have nothing to move to the right. So we're not even going to bother with it. But we'll say tile.tilex is going to be equal to get farthest open x on from the start, which is, in this case, tile.tilex, or I guess in this case it would be x, and then x, y, and what was the 4 again for that? Get farthest open x. Oh, the finish. Oh, right. Well, that's fine. We actually don't need a finish, I don't think. We're going to tweak this a little bit. And actually, most of this is going to be brought up into here at some point. But this we don't really need. We will need the occupied is true, and so on and so forth. Or rather, what we can do is we can just say local farthest x is going to be equal to get farthest open x of xy. And if it's the case, whoops, I spelled that horribly, farthest. If it's the case that, if it's the same number, so if the farthest x that we get going from left, there's like a droning sound in here. It's like, I don't know if you guys can hear that, but it is loud. Anyway, we want to essentially check this tile and all the tiles to the right of it if they are all, if any of them are open. If they are, then what we need to do is set the tile to that new tile and then create a tweening operation on it, right? So what we'll do is we'll say, where is farthest open x? It also should just return the x that we started with if it wasn't able to find anything. Oh, I see. Finish goes until the end. Oh, right. That's why we need it. OK. Yeah. Got it. OK, I see what's going on here. So everything is correct. XY4. So this will not be another function call again. This will be farthest x. But what I wanted to do is I wanted to say if farthest x is the same as whatever our current x already is. Yeah, I apologize, everybody, if that's horrible. Yeah, there's like crazy construction or something going on. I'm not even sure what's going on. Like, it sounds like a drone. Like, it sounds like an aircraft. Like a somebody just said it. Who said it? Yeah, Andre. Ultralight aircraft in the next room. It does sound like that. I am so sorry. It's loud even for me, so I imagine for you it probably sucks. But farthest x, what we want to do is we want to say if it's the same as our x already is, then we don't need to tween it anywhere. It's fine where it currently is. So if it's equal to x, then don't tween it, I guess. Or rather, if it is not equal to x, what we need to do is, and not equals the tilde in this case, then we set, we do all this stuff, right? We do the tile.tilex is equal to farthest x. We do we have to set the tile in the grid there too. So we say tile, or we say grid at y, x, or rather farthest x in this case. Farthest x. Well, no, we just do tile.tilex. Since we already derived it from farthest x, that tile is equal to tile. Cool. And then grid at y tile.tilex.occupied is equal to true. And I mean, tile and equal to tile and occupied is equal to true are kind of like both semantically useful for the same purpose. So we almost don't need this occupied is equal to true. But we'll use it. And then, oh, right. This needs to be indented, and then this needs to be indented, and then there needs to be an end here. So we get the farthest x. So working our way backwards, we get the farthest x. We set that tile to the tile that we're currently using. And then we tween. Notice that we're then tweening the x, the actual coordinate value of that tile, to its new position on the grid, tile y, tile x, right? So everything is pretty good so far, I think. I don't think we're missing anything too horribly. We'll need to sort of copy this template for everything else. But I think we can get rid of all of this now, this old code. And then let's sort of duplicate all of this. So we will duplicate all of this for move left. Except this is going to be left to right. We're iterating left to right now. OK, thank goodness. I think, oh, yes. Sarul, older grids tile will be set to nil. Excellent, excellent thing to point out there. Really appreciate that. So what we need to do then is say local old x is equal to tile.tilex. Then we set the tile x, kind of like a swap operation. Then we set the new tile x. And then what we need to do is we need to say grid, grid at y old x dot tile is equal to nil, and grid at y old x dot occupied is equal to false. Excellent, excellent observation. And Mazar Osmian says, can you please do a session on machine learning, specifically NLP? We'll see what we can do with NLP. I've been reaching out to see if we can get somebody to do it. But yeah, no promises there. It's hard to say. But we have had the neural networks sort of series of videos with Nick, so check out those. Those are some of our most recent streams, and those have been pretty interesting. OK, so I'm going to copy this revised block of code here, move this up here. And let's go ahead now. This is left to right. This is move left, so this is still great. So this is fine, but this needs to be 1 to 3 now. And then we say get farthest open x. We need to create leftmost open x. So we have a lot of functions that are, if we had more time to think about this, we could maybe generalize them a little bit better, abstract them a little bit better. But we are doing this a little bit differently. So we will say for x is equal to -1. Is this true? Is this correct? Moving right to going left. Oh yeah, and then we need to go left to right. So we get our start x, start y. In this case, this needs to be -1. And then we have a -1 step here. And then we say yep, that should be good. I think that should be good. OK, cool. Farthest x is not equal to x. Then old x is equal to tile.tilex. All this should be good, right? Yeah, we're setting it. Oh, did I forget to set the step to -1 on the other thing? I think I might have. Yeah, this needs to be -1 right there. There we go. Will you be doing something like this for Unity and Python? Maybe. I definitely would like to do more Unity stuff. I need to dig deep into Unity and come up with some pretty cool examples and spend some time with it. But yeah, that'd be pretty cool. Yeah, move tile with a function as a direction as an argument, totally doable as well. I have something like that in a personal game that I'm working on, actually. But there's quite a cost involved in upfront architecting a lot of this stuff, and wouldn't even necessarily like. There's so much involved that we might need a part 2 for this stream, even without engineering it. So we'll see what we can do. Hero says, heya. James from IT says hi. Hi, James. Cool. Awesome. So we have that set. We have this set. This is working. So now, would it work? Currently not. Am I setting can move equal to, oh. Wait. Move right and left are not working, unfortunately. Not even up and down. Oh, up and down are working. It's left and right that are not working. And actually, left and right, as soon as I hit left and right, they don't work. So let's see. Interesting. So there's clearly something in here that's preventing us from, it's preventing the tiles, like it's not getting the tiles and moving them. Like it's not doing this tween operation. Or if it is, then the numbers are not working. It'll come to me. If anybody sees it, oh yeah, Andre, yeah, that would probably work. I think if I were doing more loosely structured streams, like 8 hours, I could just sit around and screw around with Unity for like 6 to 8 hours, and that would probably come up with something. For these, since we have so little time, I feel like we have to focus on a goal, and having a goal and being somewhat familiar. I mean, even this, and I'm pretty familiar with this stuff, that we do have sort of setbacks. 68. I am not sure what that's a reference to. Let's figure out, okay, let's see, so why is moving right not working? So going through every row, for x is 3 until 1, going backwards in steps from -1, right? Tile is going to be equal to whatever the tile is at yx. Okay, perfect. If the tile exists, oh, that's what it is. Oh wait, well no, that's not necessarily the problem, because we could have multiple what we need to do, rather than, okay, so rather than having the can move is false up here, we need to have it be here. Same thing for moving left. So only set it to false if we have a tile, we have an actual tile that we can move, right? I mean, even in here, this is probably where we'd want to have it. Yeah, this is probably where we'd want to have it, actually. Here. Right. So does this work? Can I now move? Yeah, I can. Now I can at least move up and down after I'm trying to move left and right. Earlier it was freezing completely, so that was a issue. Yeah, Cerule, the farthest open x is probably the issue. So let's print it. So we'll say print farthest x, and we'll run it the command line just so that we can see it. Move right. Oh, okay, that is not at all what we want. Fascinating. 350, 490. Oh. Are we? In get farthest open x, is that? Start X, start Y, and finish. Okay. But where is... They have tile X, tile Y. That's what we care about. So move right. There's these Y and X. And then this X and Y, but hold on. X, Y, farthest X. Oh, whoops. Wait, what are these numbers printing then? What is this? Do I have another print somewhere that I forgot to get rid of? Oh. Let's get rid of that. That's a problem. Okay. Okay, so it didn't print anything that time. So it's not even getting to there, which is interesting. Move right. Okay, so yeah, I hit move right, which is up here. Key is right, move right. And we're iterating. So for y is equal to 1 to 4, so that's the whole row, the whole set of rows. X being equal to 3, so we're starting right to left with the exception of the end because it doesn't move right. So we're starting at 3. And then we're going to 1 in a step of -1, so it's like a negative for loop. Then we're getting the tile at grid y x, which is fine, if I'm not mistaken. So print tile. I need to actually move right. Oh, they're all nil. Okay. Wait, why are there only 12? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, because we're cutting 4 of them out, the end part, right? That makes sense. Okay, so the tiles are nil in this case. Blue Booger, to make a 2 game, make a 4 game. Then a 5-12 game, a 10-24 game, and 20-40 game will be easy. I love that. That's great. Maybe position in pixels, that's what's being printed? Yeah, that was. I had a misplaced print statement somewhere. My brain hurts, says Colton's hair. My brain hurts a little bit too. I need to, like I said though, never programmed this before, so we're all figuring it out on the fly together, so that's what makes it fun. I've done similar stuff with this, with the Candy Crush P-set for the games course. So it's somewhat similar, but it looks like I might have messed up somewhere one of my tables, so the grid table should be fine. Oh, are we setting the tiles to the tile itself here? Oh, that's why. Grid 1, 1, dot. So here's what we need to do. Local tile is going to be equal to this. Tile is equal to tile. And then we do it again here. We say local tile is going to be equal to this. Set this to tile. And we set grid 1, 2, tile equal to tile. OK, cool. Easy. But they're still collapsing. That's rough. And left doesn't work. But they did move to the right. They did move to the right. So it's working roughly. Now the problem is that they're still collapsing, so it's not actually flagging the tiles correctly, such that moving right doesn't overwrite those tiles. Oh, are we doing the check here? Well, no, we got the farthest x, right? So farthest x should get, oh wait, no, this is for moving left. For moving right, so farthest open x. This should have worked. Famous last words with programming all over the world. Should have worked. Always should have worked. But we're getting somewhere. So let's go ahead now and wish I had a water machine in here. I could refill my water. Let's go ahead and well, we can see what the farthest x is printing now. So if I move right, it's printing a 2, 1, and 4. 1, 1, and 4. Huh. OK. 2, 1, and 4, and then 1, 1, and 4. In this case, x, y, farthest x, but that's not it. That's not the farthest x. So what should happen is when we run this and it's correct, whoops, am I still running love? No, I'm not. And if I hit right and we look at this, this should say 2, 1, 4, and then 1, 1, 3. If it says 1, 1, 3, that'll be correct, and then that'll actually show the tiles coming together, or it'll show the tiles not overlapping. It'll show them being moved all together, but still like not going on top of each other. Now, if the proper game logic is such that if they're the same number, they should actually go on top of each other, and we can program that to be a thing. But that's for later. As is adding random numbers to the thing, so to the grid. So the farthest x is not actually giving us the farthest x. That's what's incorrect. That function is wrong. It's not working correctly. So x is going to be equal to the start x plus 1 until the finish. Oh, I see. So should we do return x minus 1? Does that work? Wow, we did it. Isn't that cool? Now, left is still messed up. Moving left is still messed up. But we do now have the ability to move all our tiles, sort of preserving their shape, preserving their layout. Nicely done, everybody. Making progress. OK. And this should be, I think, the same thing. This should be x plus 1 in this case. Cool. Now, left is still messed up. So let's figure that out a little bit. Yeah, they still mix together, which is not, yeah, that's not ideal. Okay. Did I miss anything up here with the move right versus move left? This is going positively, yeah. Tile is going to be equal to that, yep. Farthest x get leftmost open x. Oh! That needs to be 1. Okay, not what I expected, but it works to an extent. We're moving left. Let's search for a second. Okay. Racking my brain trying to get this done trying to get as much of this done in a video as I can. It's deceptively complicated. Anything that's grid-based like this that has sort of fancy workings can be deceptively hard to complete. Okay, XY1, that's good. But why is only the one tile moving and not the... Oh, wait, is it because we didn't move all of them? Do I have to make this 1 to 4? Oh, I guess I did. So why does it work with... That's so weird. Cool. We did it. Moving things around. I want to commit this. Everything should be the same, right? Yep, commit. Can move multiple tiles. Yeah, we are tweening for moving left, Bavik, which is the we put a tween inside of every movement function. All of these all have a movement. All of these ones. Yeah, see right here, right here. And we're gonna do the same thing for moving up and down as well. Because we can move up and down right now, but if we have multiple, tiles in a column, it's going to not work. They're all going to collapse again. We can test this by actually adding a few. So let's add a few more tiles. Let's go ahead and duplicate this. And this is going to be 2 and 2. So this will be 2. Whoops. And this will be 2, 2. And then this will be 2, 1, and 2, 2. Cool. So now this is great. Cool. We can move everything left to right. But if we move down, oh, actually, I currently changed the functions. So left and right are also down and up. But we can tweak the functions that we need to get this to work. And actually, I'm going to need to make a couple more functions like these for upmost and bottommost. Topmost and bottommost. So this will be topmost. And this will be bottommost. This will be start Y and start X. Well, I guess, yeah, we'll just keep it consistent. Start Y and start X. So, and this will be Y is equal to start Y minus 1, finish minus 1. Yep. This will be Y start X, and then Y plus 1. And then this will be kind of the same thing. So Y is equal to start Y. Finish. And then this will be Y and start X, and then X minus 1. Cool, perfect. So those are our topmost and bottommost functions. They're very similar to the x functions, except the x horizontal functions, except now they work for the vertical direction as well. So here, this actually needs to be reversed. So this needs to be y, or x, and then y. So we're moving up, we're going to need to work our way down. So we need to shift the tiles down, starting from the top. So this is perfect here. Farthest y, or I guess topmost y, is equal to get topmost open y. Did I change them to y as well? This has to be boom, boom, y. There we go. And then this will be, these get a reverse. This is y, x, and then 1. Farthest to y is not equal to y. Old y is equal to tile y. Tile.tile y is equal to farthest y, topmost y in this case. And then this is, these all can be x. This is x. These are x. Oh, this is tile.tile y. Tile.tile y. This is tile.old y, or rather just old y actually. Old y and old y. And then these two just become x as well. X, just like that. And then now we're tweening the x and the y. Perfect, just like we need to. Can move is true. And now we have our move up function. Now we need our move down function, which is kind of the same thing actually. So I'm just going to copy all of this largely. And then we're going to come in here. Boom, boom. We're going to go from 4 to 1, -1 this time. And then this will be bottommost. Yx, and then 4. Yes. Yes, I believe. Right? Yes. Cool. This shall be bottommost y. Far bottommost y is equal to y, blah, blah, blah. Cool. This will be bottommost y. And I think that's it. Now, can I move? Oh, whoops. 121, which needs a do. Oh, whoops. X, a nil value on main 123. Oh, got it. Why? Did I set it up here as well? Yep. 176, attempt to index a nil value. Attempt to index a nil value. Really? Can these both be just y here, I think? I feel like they could. I feel like it's the same value in this case. Right? But it's still going to be wrong, right? Yeah, attempt to index a nil value on line 182. Wait, on line 182. Attempt to index a nil value. Maybe somebody else has seen it. It's messed up. Return y minus 1. Oh, right here. Yeah, yeah, yeah. All the syntax issues. We have 3, 1, and -1 for the right direction. And it still works, which is interesting. Maybe because the... I guess yeah, it makes sense because you don't need to move the 1 to the right too much. Line 176, 177 should be tile.tile y, as that will be the new bottommost y value. Oh. Oh, you're right. Yeah, you're right. Agreed. But 176 is still... Why is it having an issue indexing this? We did not have this issue previously. Time to do some printing, right? Actually, with rightmost. Yeah, xy4, yx4, which is correct, right? We are, yeah, yx4. Oh, maybe that's why, yeah. Oh, okay, there we go. Sweet. It was an off by 1 error. So now we can move everything and the y and the x. Zoom into the bottommost function, please. Yep, short. Because of this is the problem. So if we y minus 1 off of the start, we're indexing into 0. And that is not good. That will cause issues. So we figured it out. Awesome. So the next piece is combining numbers, right? We have all the things moving around. So let's commit, right? Git commit. This is, what was my last commit message? Oh, right. Can move in the x and y. Now what we need to do is when we move right, left, up, down, whatever, we'll start with right. If we're going to a tile, right, that is occupied and has the same number as the tile that we're moving, then we should set our thing still to nil and move over, but replace that tile and combine the numbers to make a new one, right? So we'll say check if number is the same on farthest or on next occupied. So what we're going to do is we're going to say if farthest x is less than 4, or rather, yeah. Because if it's 4, we're going to the end of the board. We don't want to worry about that. So if the farthest x is less than 4, so if we're going basically to the left side, or if we're going from the left side to the right side, and we stop at number 3, but there's a tile at number 4, that's OK. But if we're at number 4, we don't want to check like the next tile over. So here's what we're going to do. We're going to say if the farthest x is less than 4, so if we're stopping at a place less than the end of the board, which means that we're bumping into a tile, we can say if grid at, and then should it be at y? Yep, y farthest x plus 1 dot num is equal to tile.num. And this is where we combine like numbers, right? That's what this is. So we say trying to figure out what would be the cleanest way to do this. And here's an interesting thing, too, because with this algorithm, we could flag the row as like, or we could flag a tile as like unmatchable, but that would be kind of complicated. But what we can do is we could say, we could let like terms like continue to stack into each other. So if like 2 4s combined into an 8, and then an 8 was moving over, like that 8 could then move over, and that whole thing could turn into a 16. I don't know if that's how the game works. I don't know if that's already built into it. But using this logic, like this foundation that we could build here, it would be possible to do it that way. That would be part of how it could work. Why not use a game engine? This is, people even mentioned it, like Left2D, you mean? I don't know. Game engines are great. This is kind of like a way to look a little bit more deeper at like, a little deeper at, I guess, like the basics of game programming, and that's kind of the point. And it's pretty easy to get up and running with something like this. Unity, you kind of have to like learn the ecosystem. You have to install Unity. It's a bit heavyweight. It's great. I think Unity is awesome. I'd like to do more Unity streams, but this is just a little bit easier. Runs a little bit more efficiently. I'm also streaming on a MacBook, and running Unity and streaming on it on a MacBook can be kind of not the greatest performance. We tried it on stream before, but you know, a few reasons. Okay, so if the number is the same, then what we can do is we can still do all of this kind of stuff. But we're going to need to do a tween with a different finish operation. Like the finish is going to have the numbers combined into 1 after it's finished, after it's over. Just trying to think of the best way to do this. It's not going to be, I don't think, terribly hard. Just trying to figure out the animation specifics. CS50, ever try Phaser or JavaScript is not up to snuff? I have tried Phaser. I was potentially going to teach a class using Phaser, but they had some issues with their, they're migrating from 2 to 3, and their documentation was just really bad for a while. So, yeah, at the time I couldn't, in good faith, adopt Phaser or use Phaser, but I have to recheck out their documentation, see if they have improved the situation documentation-wise in the last year or two. Okay. Apologize that I'm just like staring at the screen for a second. I just am thinking through sort of the animation flow for this. You're going to have the tiles, they're going to move, right? And then if a tile's going to like sync up with another tile in the same position that is the same number, then if the next tile after one is the same number, it needs to like meld with it. So it needs to like tween over to that number and then like disappear, and only one number should be there, or one tile should be there, not two tiles. And that's sort of the somewhat tricky part here. Voice keeps cracking today. I need to drink water. So let's see. All of this stuff is still going to kind of be the same. Oh, I guess. So this would be farther x plus 1 in this case, because we're going to go to the next tile over. But I don't want to set the tile to be this tile. I actually want to keep it the tile that's already there. So I'm not going to do that. I'm not going to do this either. And instead, what I'm going to do is kick off another tween over 1 second, which does kind of the same thing as this, actually. I'm actually going to do this exact same thing right here. And what I'm going to do is say can move is true, and then also does this tile live anywhere? Where does this tile live? The tile lives. It's not going to be rendered, is it? Oh, we are drawing every tile. We can say tile is equal to nil, right? And then we can say, we can do tile is equal to nil. We can do grid at, and then this would be tile.tile x, y, sorry. and then tile.tilex dot num is equal to num times 2, or it's tile.num times 2, right? And then that should work, I think. Oh, wait, did I put that in the wrong place? I put that in the wrong place. Hate myself. Tile is equal to nil. Grid at tile dot, oh, not, we have to do that above here. Grid at tile.tiley, tile.tilex dot num is equal to tile.num times 2. I think. And this needs to be in an else, all of this other stuff. Because this is what happens if it's not a match the next tile over, right? Just move over as normal. This is if we have like numbers. So now if I, let's see. I don't know what to expect. OK, that didn't work. OK, unfortunately. Oh, wait, I did the wrong. Whoops. I'm trying to remember what this farthest x is less than 4 is. Oh, I think I see what it, OK. Oh, I guess I would break. That would be what it is. Yeah. The flow is a little bit weird. So I don't actually want the else here. This actually does need to go a level back. Really, it's this. It's this is basically what I want to have happen is a break here, and then have this be like default behavior. Well, I guess no, this is fair, right? Well, as you read the chat. The code is starting to look a little messy. Yeah, the code is messy. That's the downside you have to like going all in and writing everything kind of really fast, is it starts to get a little bit tough to navigate. So even I'm having a slight amount of difficulty adding to it. So it's a good sign. I mean, Martin even says refactoring comes later. We do have a lot to do to refactor this. This stream is going to be in 2 parts, I think. I think what I would like to do for part 2, just because we are indeed getting pretty messy with the code, I think it would be cool to do like have half of, well, not even half, but like a good chunk of the next stream be dedicated to refactoring. But also we have, we have the number combinations to do. We have the randomization of 2s and 4s to come out. And we have scoring and the ability to detect a loss. I think these would be good part 2, like good part 2 problems to solve, which I think we can totally do by part 2. But yeah, right now we're at like almost 300 lines of code. Not almost 300. Oh yeah, actually we are over 300 lines of code. In one stream, which is good, but yeah, I don't know. Refactoring is kind of a mixed bag. It's good to do it up front if you know what you're doing and you know where you're going. But if you don't know where you're going and what you're doing, you could be too creative with it and lock yourself into a box. So it's good to like run into these problems and then realize sort of where you're going and what things you could then like draw patterns out of, like continuous refinement, continuous refactoring. So this is, if I were coding this sort of on my own, I probably would have done it a little bit earlier. But I think this is a great time to look at like, what are we capable of refactoring? And like, there's a lot of repetition amongst all these movement functions. So that's probably where I would start, is creating a refactoring for the movement. So have a big chunk for the movement, and then start breaking out other small pieces for like combining tiles, and maybe even create a class for the tile as well, so that we're not dealing with just raw tables, and a grid, like a class for the grid itself, and some other stuff like that. I think that would probably be a good like next steps. Obviously, we don't want to continue having mock tiles be stored in plain tables like this. I feel like it's a little bit sloppy, but I mean it's fast and simple, but it is a little bit sloppy. And like things like this, we could dedicate this to like the grid class would have its instantiation contain that, a constants file for all this stuff. But there's a lot we could do to refactor this. So I think this could be a good way to a good incentive for us to make this code a little bit cleaner. We'll probably do it next week. Whoops. Where was I at that I was just messing with? Move right, which is right here. We're at the almost 3-hour mark anyway. So this is a good time. Like, we're realizing the shortcomings of our code base here. Yeah, it's a good time to pause, I think, and to look at the code and come back to it next week and refactor it and finish it up. We got a good chunk of work done today. We have the grid, we have movement, tween animations, printing, like numerical representation of the data, and a lot of stuff. Like there's quite a bit of pieces here. We have really the main things to put together are combining the numbers, right? Coloring the tiles accordingly would be a nice to have feature, which we could do. The scoring and making sure that we can actually make a move. Like that could be pretty easily done every frame by just doing a if can move up, can move down, can move left, can move right, then keep going. But if not all of those things, then the game is not winnable, right? And that's easily done, almost reusing a lot of the code that we have now just by checking for like where's the nearest open tile if I'm going down through all of the rows, right? If I'm going left to right, right to left on the X rows, and like all of the tiles can't make a move, right? You can have a function that says can make move, right? The tile left or right, depending on which direction you're going, up or down. And if it's true for all tiles, then you have lost the game, right? That's pretty much it. So that's fairly straightforward. It It does need some work and refinement, but we'll and it's like partially broken now, so I don't even think I'll commit this most recent thing. But I did commit the biggest stable change, which was the blocks moving left or right, up and down without them merging. So that'll be one of the first things we fix next week. In addition to the refactoring. The refactoring will be cool. And I think it'll be a nice exercise for everybody to, we can take suggestions from people too. I would probably use classes, a couple simple classes, a tile and a grid class, and that's probably it. The grid would contain tiles, and then there would be functions within those, and then we could free up our main.lua quite a bit. Like our main.lua can end up being like 10, 20 lines, or not 10, 20 lines, like 30, 40, 50 lines of code, and then the bulk of it will go to the class files. And then Bavik says, game is lost when the top, bottom right, and the left tile are not the same as the current tile for all tiles. Hey, that's good too. That's even easier to program, so we could definitely do that as well. Cool. We made good progress. It's semi-broken. It's not, there's a lot left to do. There's a bit more to it than even I anticipated, but I think this will be good. This will be a good part 2 stream for next week. Yeah, we'll do it next week. We'll do it on Wednesday, if people are up for that. And then we can maybe look at a Friday Twitch codes or a code review or something. I don't know. We'll see. We'll see what people are up to. We'll see what people around the office might be interested in, what we can get people involved in doing. I know that it's been kind of tricky getting other people, to get the time to come on. But thanks to everybody who tuned in. So we had a lot of people. Wordle, I saw you a lot today. M. Kloppenberg, Bavik, NACL, Eric just popped in at the last second. Asley, Bella Cures, Andre, of course. Sarul with the clutch assistance as always, and Colton's hair, which is a fantastic name. Thank you for putting that name together, for creating that handle. And Remote, thank you very much for tuning in. Appreciate it. Oh, this is your first CS50 Live. That is amazing. Well, thank you for tuning in. I hope you enjoyed. It was a bit of a, I would say, an intermediate to not advanced necessarily. There was a lot of code. I was assuming a lot of things. It wasn't as beginner-friendly as some of our other game streams. So if you're looking for one of those, check out some of our more beginner-friendly stuff. But this does set the stage nicely for a good incentive on actually refactoring the code and making it look good, right? Because this code does not look great right now. It is very, the term that I've heard recently used a lot for this sort of thing is very guerrilla, very, very garishly constructed code. We will try and do something a little better next time. And Dan Coffey's in the chat. Shout out to Dan Coffey, 3296. Thanks for tuning in, Dan. I appreciate it. We miss you, Dan. We miss you very much. We had a slight issue with our keyer this morning, and I have a feeling you would have probably solved it instantly, but we were able to fix it. I know Tara and Andrew are amazing as well. But yeah, thanks so much for everybody tuning in. This is CS50 Live 2048 Part 1. We'll have a part 2 next week, Wednesday, 12 p.m. Eastern Time. If you're tuning in and you're not familiar with CS50 and you want to get more in tune with our stuff, go to youtube.com/CS50. Watch our YouTube videos. We have all of these videos on Twitch, or on all our Twitch videos on YouTube. And we also have David's lectures that he's taught. So if you want to learn how to program, how to solve problems, how to think like a computer scientist, and how to write code better than me, then take CS50, watch the lectures, go to edX, and join our Facebook group. Follow our Facebook page. Join us on Instagram, whatever. Do all those things, all those amazing things. But we have lots of good content out there, so do check it out. Anyways, this is CS50 Live, and we're not having another stream this week, so have a good rest of your week. Stay safe. Have a good weekend. And I will see you all next Wednesday. Ta-ta.